Good morning, good morning, good morning. All right, we're going to get started immediately. Any questions on the homework? All right, make sure you're turning these in on Teams. Remember, the quarter started on Tuesday. So if you're missing just one assignment, that's immediately an F in the class. It has an outsized effect since there's so few grades. So make sure you're turning everything in on Teams. I do grade every day. All right. We are going to start. The previous stuff was probably okay. I usually don't have too many people have problems with solving inequalities or even graphing them. Some silly mistakes, right? Dropping negatives, forgetting to change the symbol, the inequality symbol if you're multiplying or dividing by a negative. But for the rest of the chapter, that's today, tomorrow, 10-6, 10-7A and B, and 10-8, it's some weird and new stuff. All right. I'm not going to lie and say that it's so easy. It is absolutely 100%. You got to be paying attention. One cool thing because of COVID is that since all classes are recorded, you can review the class while you're doing the homework to help you out. So it's going to be another worksheet today. It is all brand new stuff today, brand new stuff. All right. We're going to get going here. I ask you to really, hyper focus on this stuff. Make sure you ask questions before you get lost. If you feel like you're getting lost, just pipe up, ask the question. So for the next 2 days, we're going to be doing something called compound inequalities. Well, we just solved a whole bunch of inequalities. Today, we're going to be doing something called a compound inequality. And on the face of it, like if you only hear every third word that I say, seems like to be very complicated stuff. It actually is not too bad, but there's a learning curve to it. Like you have to listen to all the facts, you have to understand all the processes, and then when you actually do them, you find out, oh, this really isn't that bad. All right, there are 4 things here. This isn't going to make any sense to you until I actually explain it. I see a bunch of ands and ors, and they're capitalized, and there's some graphing and breaking up. Boy, just going over the objectives won't make sense until we actually do them. So let's do them. It's going to seem like I said, if you don't pay any attention, it's going to seem like this is very complicated. You need to be a pretty smart monkey to do it. The reality is it's pretty easy, but you have to pay attention. All right. Danger, Will Robinson. Danger. No, Will Robinson. So be careful and watch out for the danger. So a couple quick notes to start things off. The first thing is, write this down in your notes. We will be doing something called compound inequalities. Compound inequalities. Well, the definition of it, believe it or not, is it's going to be 2 distinct inequalities. That means I'm going to hand you 2 inequalities, one over here, one over there. They will be joined literally, sometimes figuratively, but literally with the word and or the word or, underline and an or. So I'm going to give you 2 inequalities, right? 1, 2, right? They're distinct, meaning they're different. Well, they both have the letter M in there. They both have a -4, but one has a less than, one has a greater than, one has a 10, one has, they're not the same inequality, okay? So 2 distinct inequalities, and I'm going to join those 2 together literally with the word and or with the word or, right? Either one of those. Those are called compound inequalities. So it's 2 distinct, 2 different inequalities. The 2 inequalities will have the same variables. They will either be joined with the word and, or they'll be joined with the word or. And I don't mean like sort of kind of, I mean literally, they're going to be joined with the word and or. And yellow there is all you have to write. All right, we okay so far? All right, here we go. So the goal of what today's lesson is about is to take these 2 distinct inequalities joined with the word and or joined with the word or and graph them. That's the goal. Our goal is to graph these, but we're not going to, there's 2 inequalities. We're not going to have 2 graphs. We're only going to have 1 graph. So somehow I'm going to graph both of those inequalities onto one single graph. And that's what the lesson is about. Okay. Remember, it could be an and or it could be an or. All right. How you do it, I'm for lack of a better term, I'm going to say you're going to use these rules, and I'll call them special rules. We're going to have rules for joining two inequalities for ands, and we're going to have rules for joining inequalities that are joined with the word or. So they're going to be two different rules, one for ands and one for ors. So your goal here is to learn those two rules, and then obviously to actually make that one single graph. All right. Oh, I already circled it. All right. Here we go. A couple new words, right? We have to define what the word and what means and what the word or means. Now, obviously, you've been using these words in everyday common usage, and believe it or not, that mathematically they mean exactly the same thing. All right, we'll do them one word at a time. We'll do and first, and then we'll do or. So usually the easiest way that I can define the word and is to give you an example. And when you were little, every single night, your mom or your dad probably told you before you go to bed, I want you to brush your teeth. And maybe they also said, I don't know, comb your hair. Or maybe that's what they said in the morning, right? Brush your teeth and comb your hair before you go to work. So what the word and means, it doesn't mean you have a choice, either brush your teeth or comb your hair. It means you must do both. So the word and in this case means you must do both. Okay, so brush your teeth and comb your hair. You don't get to choose one or the other, right? You don't need to write this down. Well, it turns out that on a compound inequality, the and inequalities look like what's below here. So you've got two circles. Sometimes the circles may be open, sometimes they may be closed, and you have shading that goes on between them. This is what an and looks like. I'm not having you write this down yet. Contrast that with an or. So the best example I have for an or is this, PG-13. You are allowed to go to this movie if you are over 13, right, or 13 or over, or you come with an adult, right? You don't have to be both, right? If you can be one or the other, you don't have to be both. You can either be over 13 or over, or you can go with an adult. Either way, you get to go into the movie. That's an example of an or. So you don't have to be both. You can be either or. All right. Here is a visual representation of what an or looks like mathematically. Notice it's different than an and. An and has two circles with shading in between. Ors do not look that way. Now I am, for the true math people out here, I'm simplifying this to a 9th grade standard. Later on, as we get into Algebra 2 and pre-calculus, we'll add a little bit to this definition, okay? But for right now, this is good enough for us. Ands don't look like ors. All right. So remember I said it's going to be two distinct inequalities joined with the word and. We got one slight problem. There ends up being that there's two ways of visually writing an and. There are the two ways. Notice what the first one on the left here, it says if we solve this, add 4 to both sides, we would get that m is less than 14. We solve the one on the right here, add 4 to both sides, we would get m is greater than 10. Well, that can also be written, notice what this one says, m is in the middle, and it says m is bigger than 10, but smaller than 14. That's what both of these say. This one right here, if you solve it, would say m is less than 10. That's what this one says here on the left. And this one, if we add 4 to both sides, it would say m is greater than 10, right? I said that backwards. So here's your m is greater than 10 right here, and here is your m is less than 14 right here. Sorry for that mix-up. Yeah, that causes a problem because we can write an and inequality two different ways. The first way looks like this. Here's your first and. It will literally be a two inequalities joined with the word and. And your second way, there won't be the word and, but it will look distinctively like this. So here's your first, complication with the process is that and inequalities can be written two different ways. Now, which way is better? There is no better. They're both the same. Obviously, the one in blue is a little bit easier to write. And so many times we will choose the blue version over the, let's call it the red version right here. Tonight for homework, you're going to see both of these. All right. For those of you that are like, what in the heck is going on? I'm not really sure. Just hold your powder for a little bit. Let's see if you're still confused after we do some examples. All right. The nice thing is that or inequalities will only look like, what's there in whatever that color is right there. It'll be two inequalities joined by the word or. Okay. So ands come in two flavors, ors only come in one flavor. All right. Anybody panicking yet? Remember, our big goal here is that we're going to graph these things. All right, so now I do want you to write something down. So I at least want you to write down what's on this slide. So these are the rules for how you graph ands and ors. And the rules are this. If it's an and inequality, and compound inequality, you're going to graph both of the inequalities, and you're going to combine them only using the overlap. Now, that might not make any sense to you right now, but it certainly will in about 5 minutes. So just write it down. And by the way, if you want to draw an example of an and, well, there's one example of an and. That would be like the final answer. Ands will, you combine both graphs into one using only the overlap. Those are ands. Ors, you just simply combine both graphs, right? There's an example of what an or. And I don't want you to focus on the open or closed circle. That has nothing to do with anything right now. It's just the visually that ands are two circles with shading in between, and ors are two circles shading away from each other. Now, it does get a little bit different as we go into higher level math. Ors can actually go in a lot of different directions. But for this year, these are the ones that you're going to see. And these are your classic ands and ors. And what I was asking you to do was to copy down everything on the slide. Everything on the slide. Believe it or not, once we do some examples, you'll see how easy this actually is. But it certainly is some strange stuff as we start off. All right, are we okay to go on? All right, no one's complaining, so we're moving on. All right, I'm going to have these steps written on each slide. At some point, I would like you to copy these steps down. Step number one is we got to separate the two inequalities if necessary. Sometimes I will hand you ones that have already been separated. Step number two, solve each inequality. You already know how to do that. Step number three, we graph each inequality separately, one above the other. And then step four, we combine them using the and or the or rules, what you just wrote down. Okay, so these are the 4 steps of actually graphing compound inequalities. Step number 3 is the one that I will usually get some pushback on after you see what's going on. I will allow you to make that determination. So for the smarty pants out there, they will probably figure out a much easier way rather than making 3 individual graphs. And for the people that don't catch on, that's okay. You'll still get to the same answer. It'll just take you a little bit longer. But yes, I teach it this way because I want you to get the full idea, the full flavor of what's going on. But very quickly, many students realize that step 3 can be done a little bit easier. I'll allow you guys to figure that one out all by yourself. All right, here we go. So like I said, I will have these steps written on each slide. So if you don't have them all copied down, you can. So here are all the steps. All right, so step number 1 says to take the compound inequality and to separate it into 2 inequalities. Well, sometimes you get lucky like this one. Notice, hey, these are already separated into 2 distinct inequalities. By the way, all ors will already be separated. So there is no step 1 for ors. For ands, there can be some separation that is necessary. All right, so step number 1, we're going to break up our inequalities into 2 separate inequalities. Notice sometimes ands will be already separated, but other times, in yellow here, notice There's only one inequality. So we're going to focus on the yellow one right here. That's going to be step one to how do you break this up into two inequalities. So watch me do one. It's not very complicated. I'll show you how it's doing. So here are the rules to break a compound inequality up into two individual inequalities. You ready? I said it's going to be easy. Scratch this off. Write that inequality. 20 is greater than or equal to x. Okay? Why is this not clicking? There we go. Step number 2. Erase the other side. Erase this side and write what's there. X is greater than or equal to 7. Right? Put the word and there are your two distinct inequalities. Let's see that again. How do I do this? Oops. Step number 1. Now, obviously, you don't have to literally scratch this off. Sometimes I say take your hand and cover it up. Write that inequality as it states. It says 20 is greater than or equal to x. Step number 2, scratch out the other side. Write that inequality. Combined with the word and, x is greater than 7. All right, here's where I got to stop and make sure that that point was clear. Was that point clear with you guys of how you break that up into two distinct inequalities? Chris, you good on that?
Depends.
Speak more. Tell me what you're confused on.
I thought it was like
Do you understand what I did there? All I did was take a pen and scratch off one side of it, the number and the inequality. See what I did there?
yeah,
And what does this say now?
x is greater than 7.
Goes right there. Okay. Then what do? I do the same thing except the opposite, right? I scratch out the other side. So I'm going to scratch out the inequality symbol in the number and I write that right there. And then I put an and that joins the two. That's literally all I'm doing. Like, I'm not even sure if that's math, right? It doesn't feel like it, right?
Okay.
All right. Well, that takes care of Chris. What about Riley? You okay with this?
Just gonna close.
Yeah.
Okay. And I can't tell who the other person is because they always have some weird name. But other person, are you okay with this?
Yeah, I'm good.
Who is that?
Piper.
Okay, Piper. Piper has the 26 letters of the alphabet name. All right. Okay, so that's how you break it up. So once again, Chris, tell me what to do here to break this up.
You put you scratch out the negative 16
And the inequality, all right?
in the inequality, yes.
Okay, and you write what?
X is less than 0.
Okay, and then you do the same thing to the other side.
Then you
I
put
scratch
down
this out and I write.
negative 16 is less than x.
Okay, and I combine those with the word and you're done.
Oh.
Pretty simple,
Okay.
yes?
Is that for the whole entire homework?
Oh boy, would it be nice if that was it.
Dang.
But yes, for the entire homework, when it asks you to graph a compound inequality, step 1 is break it up into two inequalities. That's what you're going to have to do. Now, I do want to point out one other thing is that sometimes you will be given this as the starting point, then there's no step 1. But when you're given in red here, when you're given this, step number 1 is I got to break that up into these two inequalities. Okay, we good?
Yep.
All right. So that is the easy step. Let's break this up. Riley, take the first one. Tell me the two. And I just simply go left to right is when I typically do this. Go ahead.
-3 is greater than x. I should say that right. And x is greater than or equal to -9.
Very good. All right, Piper, can you do the one on the right?
-1 is, I forgot what the signs mean.
Less than
x, and x is greater than equal to 20.
It would be less than or equal to
less than equal to 20.
All right. So you guys are all doing fine on that. That's your first step. Done. All right. Believe it or not, that's one of 4 things. So that's not bad. All right. All right. So now let's get to what the final answer is. The final answer is a graph. So here we go. We'll do the ands first, and then we'll circle back and we'll do the ors. All right. So step number 1, remember step number 1 is separated into 2 inequalities. All right. Well, we just did that. Chris, do this one.
1. I mean, we cross out 1 is less than
You
x.
can just tell me the answer.
Oh, 1 is less than x, and x is less than 3.
Less than or equal to 3. There you go. All right. Very good. Well done. Okay. Here is what, and remember I said this is the part that you might have some pushback on for the smarty pants out there. Step number 2 says to solve each inequality. Remember, solving means we get x all by itself. Notice x is all by itself, right? There's nothing on that side with it. We will get to some where we have to solve here in a little bit, but for right now, notice there's nothing to solve here. They're already solved. So we're going to move immediately past solve to graph, one on top of the other. All right, so all we're going to do is simply do what we did for the last couple of homeworks, right? Is simply graph each one on top of the other. All right, so first one, let's see, open circle, shade, what is it, right, with a 1? You see that? Notice I didn't put 1 in the middle. You'll see why here in a second. Second step is to graph the next one underneath of it. That would be closed circle on 3, shade left. You see what I did there? Like, well, why didn't you put 1 in the middle and 3 in the middle? Well, compound inequalities, now we got to use some numbers. So how do you know how to make these numbers? And I will tell you how to do it. Look at both. I'll do this in blue. Look at both Look at both numbers, okay? You need to have a graph that at least goes from 1 to 3. I need a graph that at least goes from 1 to 3. So when you do that first graph, I don't need to put a 0. I don't need to put negative 1s, because the graph is going to go from 1 to 3. So I notice my graph goes from 1 to 9. Okay, a little bit of overkill right there. Okay, but my graph needs to at least go from 1 to 3. Okay. Graph one on top of each other, done. All right, who copied down those rules for the ands? Can somebody read me the rule? How do you combine those? What do your notes say? What are the
Do you
rules?
want step 4?
Yep.
Combine using the rules for and or.
So what's the rules for and?
That we put them on top of each other.
We do, and we only show the overlap. All right, can you see the two that are one on top of each other right now? Imagine in your mind eye, if I squeeze those together, if I squeeze them together, where would the red overlap? Between what 2 numbers? If I took those 2 graphs and squeezed them together, the 2 red squiggles would overlap. Where would they overlap?
In between 1 and 3.
And that's the answer. And this is where I usually get some smarty pants say, oh, I can figure out a whole easier way of doing this. And that's fine. But I want you to understand that what we're really doing is we're squeezing these 2 together and we are showing the overlap. And by the way, the red represents the answers, the solutions to this. I did it again. The solutions to this compound inequality in blue here. That's the compound inequality. It says the red is the solutions. Any number that is bigger than 1 but smaller than or equal to 3, that's why it's got a closed circle, makes this true. Does that kind of make sense? Somebody, anybody? All right, I guess we have to do some more. All right, so let's do some more. Let me pull up another example here. Clear this one out, and we'll do another example. Okay, here we go. Step number 1, separate into 2 inequalities. Go, Piper, separate it. Piper, you live?
I didn't unmute.
Okay.
2 is less than x, and x is less than or equal to 7.
Perfect. All right, so there are my two inequalities separated by the word and. All right, we're going to graph both of these. So the big question is, well, what does my graph need to go? It needs to go from at least 2 all the way up to 7. Okay, so my first graph, x is greater than 2 with an open circle. And my second one is x is less than or equal to 7 with a closed circle. Okay, the final answer are these two squeezed together with just the overlap. So notice the overlap, if I move this one down and I move this down here, right? The red squiggle right here would overlap between 2 and 7. Can you see that? Can you picture that in your head? So the overlap would, well, the 2s would overlap and the 7s would overlap and everything in between them. But 2 would have to remain an open circle and 7 would have to remain a closed circle. And literally that red squiggly line on the yellow there, represents the solutions to our compound inequality. Any number, like 4 is in here. So 4 is bigger than 2, but less than or equal to 7. 6 is bigger than 2, less than or equal to 7. 2.1 is bigger than 2, less than or equal to 7. All right, I usually pause right here and simply ask where we're at. Are we total confusion, a little bit of confusion, or okay, I kind of got this. Riley, where are you at?
I have it.
All right, where are you at, Chris? Chris, where are you at?
Hi. Sorry, what were you saying?
This is where I ask people, are you totally confused? Are you a little confused? Or no, I kind of got this.
Oh, yeah. I think I got this.
All right, how about you, Piper?
I'm good.
All right. All right, so let's just run through these then. All right, here we go. Riley, break this sucker up here, number 4.
-5 is less than x, and x is less than or equal to 7.
Okay, perfect. All right. Have you figured out the easy way of doing this yet?
Yeah.
All right, so what's the easy way of doing it?
So for the number line, it's just -5 through 7. And then you do the open circle for 5, -5, and the closed circle for 7. And then you just fill in the center.
All right, you got it figured out. So why am I making you do this the more challenging way? Well, I just want you to understand mathematically what's going on here. I don't know, Chris and Piper, you picked what up she said, but yep, she's figured out the easy way. So I never would require you to, to do this and this if you don't want to, if you've already figured out how to get to the answer just by looking at this. And absolutely 100% that is true. Now, there will be a reason why we break this up here in a second, Riley. It won't be that this is always this easy, but for the ones that look like this, oh, heck yeah, go from here to the answer immediately, okay? We'll do the more complicated ones now. All right, we okay, Chris and Piper, to move on?
Go on.
All right. So let's do the more complicated one. So Riley, here's one where you can't look at it and say, oh, this is what the answer is. This one, we got to do some work to it. All right. So go ahead and break this one up, Riley.
Would we just put the -4 with the m?
Yes, you would.
Okay. So -3 is less than or equal to m-4. And m-4 is less than -1.
Okay, so there are my two inequalities. Now, remember, there were 4 steps here, and step number 2 said to solve the inequality. So this one we have to actually solve. Okay, it's not that bad. Okay, so what do we have to do to both sides here, somebody? What do we got to do to both sides to solve this for m?
Talking to me.
Either one, that's fine.
Anyone.
Oh, okay. You have to put an and.
I already did that, but now I'm solving the inequality. Previous one, there was nothing to solve. Now I'm
X.
solving the, what do I got to do to both sides here?
You gotta put a, I don't know.
Is m by itself?
No,
What's attached to it?
-4.
How do we get rid of that?
At +4.
Both sides. So we add 4 to both sides, and now we have our inequality that we like. All right. We do the same thing to the other side. We add 4, and now we get our 2 inequalities joined by the word and. So here is an example of, Riley, where you can't just look at it and write the answer. So you have to solve these 2. And most of them are like that tonight for homework. All right, so here's my 2 inequalities. Notice I needed I used a whole page to do that. Now I'm going to graph these 2. So you can still use your basic idea, Riley. I need a graph that goes from what? I need a graph that goes from 1 all the way up to 3. And then you can kind of figure out just by looking at the symbols right here of whether you need an open or closed circle. But the first one, m is greater than or equal to 1, so closed circle, shade right. And the second one, m is less than 3, so open circle, shade left. The overlap would be the 2 squeezed together. So sometimes for kids that have trouble with this, I just simply say, well, you're going to drop that circle on the top straight down. So we're going to have a closed circle here. You drop the other circle straight down. So it's an open circle, and you simply shade in between. Does that help you? Does that make sense? Some people can just look at this inequality and this inequality and graph the answer. Other people will need to graph both of these inequalities and do the process that I just said. Drop the circle straight down, drop the circle straight down, and shade in between. Okay. We okay, everyone? Oh, I didn't give you the answer, did I? There you go. There's the answer. And this answer represents, if I go way back to so any number between 1 and 3 that is smaller than 3, if I go way back to the original inequality, that's what would make that true. Any number that's greater than 1 but less than 3, like 2, right? 2 minus 4 would be -2. -2 is bigger than -3, but smaller than -1. So that's what the big picture of what this is all about. It's about finding the solutions to a compound inequality. All right, we need to do that one again. Ooh, look at this sucker. Chris, can you break that one up?
Yes.
Process doesn't change, exactly the same way.
Right. So I guess we just add add 6 to both sides.
Break it up first.
Oh, it's 2x
About
-6. 1 with the weird arrow thing.
Less than
2x minus 6.
Over 2. And the second one?
Less than 6.
Yeah, but we got to say it correctly.
Is less than 6.
Well, now remember, when we scratch things off, we'd be scratching this off. So read me everything that's left.
2x -6 over
Minus
2
6
is less than 6.
Over 2 is less than 6. Okay, so those are my 2. And once again, for those of you, Riley, that figured out, hey, I can just graph right from this. You can't do it with this one. So we have to break this up into 2 inequalities. All right. Now, Chris, you have a choice. I can either get rid of the 2 or the -6. Which one is the easiest one to get rid of?
The 6. No, the 2.
The 2. So we're going to get rid of the bottom 2. How do you get rid of divide by 2?
You subtract. You multiply.
You multiply by 2. So we're going to multiply both sides by 2. Stop me if I'm going too fast here. Those 2's would cancel. Oh, we got a lot of work to do here. 2 times 1 is 2. So you get 2 less than 2x minus 6. Now what, Chris?
You do the other side.
We could, or we could just finish this one.
2 is less than 2. 2 is less than 2x -6.
Yeah, which one are we going to get rid of? 2 or the 6?
The 6. No, the 2.
No, 2. The 6 is right. So let's add 6 to both sides. If I add 6 to both sides, I get that. Last step,
We get rid of one of them?
Well, do it.
2.
So do it.
2x.
You said 2 and I said do it. Get rid of the 2.
Oh, now it's just 8x. 8 is less than x.
Because you just made the 2 disappear. How'd you make that 2 disappear? How is
I
it
don't
attached
know.
to x? Do the inverse.
Oh, I just divided it.
Both sides, though, not just one side.
2x negative 6 over 2 is less than 6.
Whoa. Hold on. You just said divide both sides by 2.
Oh, okay. I'm sorry, because it's kind of like on the lower part of the screen, so I'm
It
looking
is on the
over
lower
here.
part of the screen. So what do you get for a final answer there?
Just 8.
8 divided by 2 is not 8.
Shut up, Piper.
Let her talk. She's correct.
It's 4.
It is 4. All right. So after you do that, you get that right there. All right. I'll do the other side for you real quick. Same process. Oh, be careful. Remember, we're in inequality land. So if we ever multiply or divide by a negative number, we would have to flip the inequality. You might see that for 1 or 2 questions tonight for homework. So on the second one, we're still going to multiply both sides by 2. 2's would cancel. Add 6 to both sides. Divide by 2. I used up this whole page and I haven't even graphed anything. Are we okay with just the algebra there, everybody?
Yes.
Okay.
Yep.
So now I just do the graph. Let's see, what numbers do I need on this? Well, it needs to be bigger than 4, but smaller than 9. So I need a graph that goes at least from 4 to 9. All right, so let's do that. There's the first one. X is bigger than 4. X is smaller than 9. On my combined graph, once again, I drop the first circle straight down to 4. I drop the second circle straight down to 9, and I shade in between. Notice both of these were open circles. Okay. Chris, what do you think besides the algebra?
He's getting food.
I probably would pay more attention to this. What do you think, Piper?
I think it's I feel like I could get confused and then like if it got like really hard, like really big numbers.
Right.
But besides that, I think I get it.
Okay. I would recommend when you're doing your homework that you have this video playing and you do it one step at a time. Obviously, the homework, the numbers will be different, but the process is still the same. All right. What do you feel like, Riley?
I'm fine.
All right, good. All right, one last one, and then we'll move on to ORs. Okay, so I'll do this one. You guys can watch. Let's see. I break it up into 2 inequalities. Well, there's your first one. There's your second one. Then I solve each. Remember, you just got to be careful. A couple of these you might have to multiply or divide by a negative number. You'd have to flip the inequality around. This one I don't. To solve this one, I'm just going to subtract 2 from both sides. 2 minus 11 is 9. And then this is what, and it's combined with an and this is what I'm going to graph. So I need a number line that goes from 3 all the way up to 9. This one goes from 0 to 10. I'm just being lazy and using a simple number line. So 3 to infinity, and the other one goes from 9 to negative infinity. And then I simply make a combined graph. And when I say make a combined graph, you're going to drop that circle straight down. It's solid. You're going to drop this circle straight down. It's solid. And then you shade in between. And what that shading represents, the shading right here, are all the answers. 4, 5, 6, 7, 8, all make this inequality true, like 5. 5 plus 2 is 7. 7 is bigger than 5, but less than 11. Okay. Notice this one also had solid circles. So those numbers are also part of the solutions. Like 3, they can't read it because I scratched it out. 3 makes this true. 3 plus 2 is 5. 5 is less than or equal to 11, but it is also greater than or equal to 5 as well too. So ultimately, this second graph, let me make it nice and pretty now. Ultimately, this last graph represents where all the solutions live, and that's the real purpose. We are solving a compound inequality, and the graph represents where are the numbers that make this original compound inequality true. All right. We okay to move on to ORs, everybody? All right, we're moving on to ORs. Here, I had one extra one for practice if needed. All right, we're moving on to ORs. All right, so for ORs, it's the same process. It's just that last step of combining the graph that changes. So the only thing that changes, the entire process is the same. The only thing that changes is this part right down here. When you combine the graphs, you're not going to use the overlap. You're going to use everything. I mean, everything. So here's what that means. It means step number one, well, the nice thing with ORs, they will always be broken up. You simply graph both of these on one number line. I'm going to graph, well, let's see, I'm going to graph this and I'm going to graph this on one combined. It says use combined graphs. So I'm going to graph both of those on one number line. We still have the 4 steps. We got to separate, then we got to solve. We graph them on top of each other, right? But I'm going to use a combined graph. So let's see, what would a combined graph look like? Well, as previously stated, I drop the 4 down here. I drop the 6 down right here. And then I don't do the overlap. I use everything. In other words, all I did was combine these two. I literally just shoved the 2 together, and this represents all the solutions. Notice that's kind of weird. That means that, well, 8 is a solution, so is 2. 5 is not a solution though, right? 5 is not bigger than 6, but it is less than 4. This is one of those, remember, PG-13 ones. You can be one or the other. You don't have to be both. You could be 8, and then 8 makes the left side true, but 8 doesn't make the right side, this inequality, true. But that's okay because it's an or. That would not be okay with an and. You got to brush your teeth and comb your hair. You got to do both, okay? Hopefully you're not lost in that analogy there. All right, let's see that again. The nice thing is that all ORs will already be separated, so there really is no step 1 here. There's just solve this sucker. Hey, look, it's already been solved. Step number 2, we graph, right? One on top of the other. And then we combine the graph using the OR rule. The OR rule means I just simply squeeze these 2 things together. It's literally taking the top one and the bottom one, squeezing them together. So let's see, if I squeeze them together, I'm going to have an open circle on -1, drop the 2 down. I'm going to have an open circle on 2, and then I use both of the shadings. So it's going to look like that right there. Now, can you get that from these? Sure can. You can start off, okay, I'm giving away the smarty pants answer. Here's the smarty pants answer. You just graph what it says here. It says n is greater than 2. Now, you got to remember there's always going to be a big number and a small number. Small number goes on the left. The big number goes on the right. The problem with doing it this way, you got to figure out how many tick marks are in between. Let's see, that would be 0, 1. Okay, that one wasn't too bad. We got an open circle here. We got an open circle here. It says n is greater than 2, and it says that n is less than -1. So you can do this smarty pants method way, but boy, you got to be careful that you have the right number of tick marks, and you're giving enough space, and you've read this correctly. All right, did I just cause some confusion there? Anybody? All right, good. All right, so there's your combined graph, nice and pretty this time. Let's do one together. All right, here we go. So this one is it's got all the steps, other than, remember, it's an or, so it doesn't have that first one. So here are 2 distinct inequalities. Well, step number 1, break them up. They're already broken up. Step number 2 is we got to solve these. Now, remember, when you solve, if you ever multiply or divide by a negative number, you have to flip the inequality. All right, so Riley, what do we do on the one on the left?
We take 5, and so we subtract by 5 from both sides.
Okay. Done. How about the one on the right?
We divide by 7.
Are we dividing by a negative?
No, positive.
So we do not have to flip the inequality. But if that had been a -7, we would have needed to flip the inequality. You're going to see that tonight, I think, once or twice. All right. That is what we're going to graph. All right. We're going to graph the first one. Let's see. It says n is greater than -1. That would be with an open circle. And the second one says n is less than -5. Also with an open circle. The final answer are these 2 graphs squeezed together. So I need a graph where I've got an open circle on -1 and it goes to the right, and a graph with an open circle on -5 and it goes to the left. Visually, what am I doing? I'm just taking the two graphs and moving them straight down. I'm moving them straight down. If it was an and, we would have the overlap. By the way, if this was an and, there would be no solution here because there is no overlap. Notice the graphs do not overlap each other. That's why this one's an or, not an and, by the way. Okay. Possibly when you get to Algebra 2 pre-calculus, you might see that, but not this year. All right. Questions? All right, let's do one more and we'll call it a day. Here we go. One more, we'll call it a day. All right. Well, this has got a lot of meat to it. Chris, what do you think on the left? What's the first step?
Let's see.
You get rid of the 3 or the 2?
The 3.
Always get rid of addition, subtraction first.
Oh, the 2 then.
So how do we get rid of the 2?
Subtraction.
And that would give me 3x is less than 9. Now what? What's attached to x? How it's attached? Do the inverse.
We do subtract 3.
Because it's attached by addition, yes?
Yes.
Where do you see a plus?
Sorry, we're doing the 3x 9 one.
Yep.
Sorry, wrong one. It's subtraction, not subtraction. Sorry, I said that already. Division.
It is. Divide both sides by 3. We are not dividing by a negative, so we don't flip the inequality. There you go. All right, Riley, do the second one. Ugh, I already wrote the answer. Darn it.
We subtract by 5.
Okay, that's
And
going to be
then-
negative 32.
Mhm. And then we flip the sign and divide by
Because-
-4
Why do we flip the sign?
because we're dividing by -4.
Because we're dividing by a -4. Therefore, you would get x is greater than or equal to a positive 8. Okay. Why did I do that? Because on that step right there, I am dividing by a -4. So I have to flip the inequality. Okay. There we go. There's my 2 inequalities right there. I graphed the 2, right? X is less than 3 with an open circle, and x is greater than or equal to 8 with a closed circle, right? If you want to be really lazy on this, right, obviously you would just simply take those 2. You'd start off with the 3. It's an open circle. And then somewhere over here, you'd put an 8, but you really wouldn't know where to put it. So if you're going to do it that way, I would recommend go do this. Put the 3 over here and then count up to 8. 3, 4, 5, 6, 7, 8. That way you can assure that you have enough space, because if you don't do it that way and you're like, I don't know, maybe 8 goes right here, and then you try to put tick marks, you kind of run out of space. Okay. So my recommendation, if you're going to use this shortcut method right here, you put the 3 there and then you count up to wherever number you're going to, in this case 8, and then you will ensure that you have enough space. We do need to put the arrows. My shading is horrible. I haven't taken Miss Kittle's Drawing 1 class, but there you go. All right, any questions on that one? Let me do it nice and pretty now. Oh, I did do it. Believe it or not, that was the whole darn thing. We graphed ands and we graphed ors. I start off by saying, for some people, this is a challenge because you only heard every third word of what we did. And for other people that paid attention, you kind of found out that, oh, this is actually pretty simple. There is so much in math that's like this, that if you pay attention, it actually ends up being pretty simple. But if you just throw this at someone, you don't have, I don't know, you don't have a sense of where to go with this. Right? If I hadn't given you this instruction, you'd be, floundering around saying, I don't know what to do here. And so I just use that as words of encouragement to always, put forth an effort to pay attention. You will get there if you pay. If you don't have much choice or much chance of getting this. Any questions before we end up here? How am I doing on time? I think I'm right on time. Yeah. Bell's about to ring. Right on time. We'll end it right here. I will see you guys tomorrow. If you do try to do your homework, I would recommend play the video. I'll have it posted within about 15 minutes. Play the video while you're trying to do your homework. It'll make much more sense. So you guys have a wonderful day. Yes, I'm talking fast so I can end this before I'm a minute over. I will see you guys tomorrow.